Here we're going to be looking at factoring a trinomial, especially with a leading coefficient here. This time I'll be doing a more visual method. So we're still going to start with a diamond and taking our a value, or our coefficient of x squared, and multiplying it by our c value. So we still get 15 up on top, like we were doing with the earlier method I showed you. And now we're going to be looking for numbers that add to negative 16, to the b value. So numbers that multiply to 15 and add to our b value. So you can take some time to do that. This is interesting. It's a positive 15, so that means that either my factors are both positive, or they're both negative. Well, which set of factors here also adds to negative 16? This one does. Now if we think back to, by the way, this doesn't need to be there. So we really make a diamond, and then we're going to use this diamond to put the areas of our different regions into this square or rectangle right there. So in this top left square we'll put our 3x squared. Those were our big squares when we were multiplying polynomials together. We usually had some big squares in the top left. Then we had some rectangles over here. Remember, rectangles are x's. Well, here's where when we get our answer to the diamond problem, we're going to, instead of showing negative 16x, we're going to show whatever our solution here is with that variable after it. So negative 1x and negative 15x. This replaces the negative 16x right here. So those two sets of rectangles combine to make negative 16x. And then our positive 5, usually we have some small squares towards the bottom. That would go right there if we were to give a very detailed picture of this. But instead of drawing out the big squares, we just put x squared. Instead of drawing the rectangles, we put x. And instead of drawing the small squares, those are just constants. So now from here, we are going to factor up and out. To get our dimensions of this new rectangle, or our dimensions of the rectangle, we're going to factor up. What goes into, so to find this one, I'll factor these two terms. What can I factor out of them? An x. What can I factor out of these two terms? A 5. What can I factor out of these two terms? A 3x. And what can I factor out of these two terms? A 1. Now something that we'll need to check with is the signs. When I multiply 5 and 1 together, so essentially right now I'm thinking my answer is something like this. These two dimensions become the binomials in my solution. X and 5 were together. Then look at your signage. These need to be negatives in here to get a negative 15x. When I took 3x times negative 5x, I get negative 15x. And this needs to be a negative 1. Negative 1 times x is negative 1x. But still, when we multiply the negative 1 and the negative 5 together, we get a positive 5 right here. Put the negative sign right there. That looks better. So this is our solution. Now it's a little bit quick, a little bit different. Let's try that one more time. So we're going to make a diamond. So I see a trinomial, nothing I can factor out, and a leading coefficient other than 1. So we're going to take 2 times 6. We're going to look for numbers that multiply to positive 12 and add to our b value, which is 7. We get 3 and 4. That's going to replace the 7x. So that means I need to put x's after them, because 3x plus 4x is 7x. We're going to use that in place of this. So now let's put our big squares, this first term right there. We're going to have 2x squared. And then instead of the 7x, we're going to put 3x and 4x. Now you could switch the 3x and the 4x. You could put the 4x there and the 3x there. That's fine. And then 7, just kidding. We're writing down this polynomial. The 6 goes right there. So now we factor. This is maybe where things got a little bit goofy. Back a couple weeks ago, we knew the dimensions. We knew the factors, or what the answer of this polynomial looked like. Let me say it again. We knew what the dimensions looked like. And we were trying to find what the total area was combined with all those different shapes. Now we know the total area are all the different shapes, but we need to find the factors. So to do that, we're going to figure out what things should go right here. And to figure that out, look at what factors out of just these two terms. You can factor a 2 out, because 2 goes into 2 and 4. And you can factor an x out, because these both have x's. To figure out what should be here, take the GCF of these two terms. These two terms right here, the GCF is 3. To figure out this term, take the GCF of these two terms. There's not a number that goes into 2 and 3 other than 1, but I can factor an x out of each one of those. And then out of these two terms, I can factor out a 2. Last thing, you just want to think about your signs, if we should have 2 positives, 2 negatives, or 1 of each. So let's try, well, since this 6 is positive, since we needed to multiply to a positive 12, either they're both positive or they're both negative. Since it works that we can take 3 plus 4, they both are going to be positive. So 2x plus 3, x plus 2. And you can also see that when you multiply a positive 2x and a positive 2, you get 4x. When you multiply a positive 3 with a positive x, you get positive 3x. And you get positive 6 down here also, if they're both positive. So there's our answer. Last one. So now we're, again, no GCF, but we have a leading coefficient. So we're looking for ways to multiply to negative 24, because it's negative 6 times 4. And add to 5. So, since this is a negative 24, we're thinking on our list of factors of the number 24, since it's a negative 24, one number is going to be positive and one number is going to be negative. And really, what they're saying is the difference between those two numbers is 5. So I like this combination right here, but I need to think about which number. I like this combination because the difference is 5. And I'm thinking difference because one of the numbers needs to be negative. So which number do I make negative so that when I add them up I get positive 5? Right there. Negative 3 plus 8 is positive 5. So now remember, that replaces our 5x. Adding these together combines to 5x, which is equivalent to this. So I'm not going to write down 5x. Instead, I'm going to write down negative 3x and positive 8x. In our corners, we put the 4x squared and the negative 6. All right. So to figure out this top value right here, think about what we can factor out of these two terms right here. Factor vertically. We can factor out an x. What can we factor out of these two? A 2. What can we factor out of these two? That'll give us this part of our binomial right here. We can factor out a 4x. And out of here we can factor out a 3 or a negative 3. Let's factor out a negative 3, and then we can just check to see if that works. So is negative 3 times x negative 3? Yes. Is negative 3 times 2 negative 6? Yes. And all these two factors up here also work. 4x times x is 4x squared. 4x times 2 is 8x. So our solution is 4x minus 3 times x plus 2. That 2 is positive. Bada bing, bada boom.